Welcome. Let me show you what makes this Minesweeper game special. As you can see at the front, we have a beautiful terminal-based interface with colorful ASCII art and a clean menu system where you can either start a new game, view the leaderboard, or exit. Now, let's start a new game. This is the instruction screen. Here you will be shown the objective, commands, symbols, and tips for the game. Make sure to read all of them before starting the game itself. Next, you'll be asked to select the difficulty of the game. Here you'll be shown the best times for the 4 different game modes: easy, medium, hard, and expert. Different game modes will have different grid sizes and different mines. The speedrun mode, you will have a 60-second time limit to solve the game, and you'll be given extra time if you select the correct surprise boxes. Now let me guide you through how to play the game. In the game screen, you'll see the remaining mines, hints, and your time. The actions are R, roll column for reveal, F, roll column for flag, H, roll column for hint, and Q for quit. The keywords R, F, H, and Q represent reveal, flag, hint, and quit respectively. If you wish to reveal a mine location, type R, row, and column, and it will reveal the selected location. The cells replaced by a dot indicates that there isn't a mine in that cell, while cells replaced by a number indicates the number of mines adjacent to the cell. These cells will not have a mine. If you wish to flag a cell, you can type F, row, and column, and it'll replace the cell with an F, indicating that you have flagged that cell. If you wish to unflag, you can type in the same commands, F, row, and column for the same coordinates, and it will unflag that cell. If you're lost, you can access the hint feature, which briefly shows you all mine locations in a given game plan. You can type H, row, and column to access this hint feature. This is our mystery box feature. You can choose one of 3 mystery boxes, 1, 2, or 3, to receive different gifts or items for the game. Let's choose box 1. Now, after the animation, we can see that we've discovered a mine location, which is on 2,1. If you step on a mine, you'll be shown the game over screen, and you can press enter to return to the main menu. If you select all cells without mines, you'll be shown the win screen, where you'll be shown the time taken, and a place where you can type your name to be added to the leaderboard if your time was fast enough.
Let's explore the technical implementation. Our code base is modular and well organized. We have separate modules for game logic, UI, rendering, input handling, and game features. The heart of the game is in GameLogic.py. Let me show you how we handle the core mechanics. First, the place mines function. Notice how it excludes the first click and its neighbors, ensuring players never lose on their first move. The function uses Python's random sample to select mine positions from the available cells. This creates a fair and random mine distribution. Next, computer counts calculates how many mines are adjacent to each cell. It iterates through all mines and increments the count for each neighbor cell. This creates the numbered grid players use for deduction. One of the most important functions is flood reveal. When you click a cell with 0 adjacent mines, we use an iterative stack-based approach, not recursion, to reveal all connected empty cells. This prevents stack overflow. The reveal cell function orchestrates the reveal process. It checks bounds, handles flagged cells, detects mines, and triggers flood fill when appropriate. Notice all the input validation. We handle edge cases to prevent crashes. Win detection is simple but elegant. We check if the number of revealed cells equals total cells minus mines. This happens every game loop iteration. Data structures are key here. We use sets for mines, open cells, and flags. Sets give us O1 lookup time, which is crucial for performance. The count array is 2D, list for efficient number storage and retrieval.
Now let's look at how we create the visual experience. The UI model handles terminal interaction, and the board renderer creates our beautiful game board. First, our colors class manages ANSI escape codes for terminal colors. The render board function takes our game state, mines, counts, open cells, flags, and converts it into a formatted color string. Now for the surprise box feature. The show surprise box and the generate reward function randomly creates different rewards, and the check surprise box function gives players a chance after each move. We store data as difficulty, name, time in a text file. The load leaderboard and save leaderboard function handle persistence, and we sort times to keep only the top 10 per difficulty. Our user command function validates all commands, checks bounds, and handles errors gracefully. This prevents crashes from invalid inputs. Finally, notice our modular architecture. Each file has a clear responsibility, like GameLogic.py handles rules, UI.py handles display, and GeneralTester.py orchestrates everything. This separation makes the code maintainable and testable.